Hi guys, I am going to try a recorded lecture today and see how this goes. This way you guys can go back and watch this again if you miss something or slow it down and pause it. And also be good for kids when they cannot come to school. So we'll try this out and see how it goes. Today we're talking about Unit 2 and more specifically sections 2.1 and 2.4. So we'll start with 2.1, which is learning the properties of matter. So let's start by defining extensive properties. So extensive properties depend on amount of matter in a sample. So things that are extensive properties that we have probably heard before is mass, which is the measure of the amount of matter object and object contains. And the other very super common one, which we'll talk a lot about in this class, is volume, which is the measure of space occupied by an object. And so we have extensive properties, again, properties that depend on the amount of matter. And then we have intensive properties. These depend on the type of matter. Not amount. And so an example that I listed here would be hardness. The hardness of an object depends on what it is, for example, a rock versus a pillow. But it doesn't matter how much of each of these you have, the hardness should not change. It only changes if you change the type of matter. And then let's define substance here. Let's define it as a matter with uniform and definite composition. Composition. And so this little asterisk here, this is a key concept, and that is every sample of a given substance has identical intensive properties. This has to do with the fact that every sample has the same composition. So if intensive properties depend on the composition, then every sample of a given substance should have the same intensive properties. Now let's move on to physical properties. A physical property is defined as the quality or condition of a substance that can be observed or measured Here's the big word. Big keyword is without changing substance composition. And we'll get more into physical properties during class today. But let's talk about the three main states of matter. These also should be familiar to you guys. The first being solid. And solids have definite shape and volume, meaning they're not changing. Next would be liquids. These have indefinite shape, so you should know this. If you spill a cup of water, it changes shape as it goes across the table. So liquids have indefinite shape, but they have a fixed volume. Then the last state of matter is going to be gas, which has indefinite shape and volume. So gases are special because they're easily compressed, so they can change their shape and volume. So if we scroll down to the bottom here, I just attached some pictures of typical how it would look if we saw them as at a molecular state. So water molecules, this is all examples of water because we know we can see it as ice, water, and water vapor. So it's a good example of solid, liquid, and gas states. So when it's a solid, it's very rigid. And then as a liquid, there's a little bit more movement. And then gas, where there's a lot of space and movement in between. Remembering that solids cannot change shape or volume. Liquids can change shape but keep the same volume. And gas will typically fill whatever space it's in. So it does not have the definite shape and volume. I'm going to pause here if anybody has any questions. Okay, now looking more closely at physical change, I wanted to point out that physical change and chemical change, knowing the difference is going to be important, but we will do a class activity today to help differentiate between these two things. But a physical change is defined as a change of some properties but the composition does not change. And what I mean by composition is just the composition of material. So, an important thing to note about physical changes is that they can be classified either as reversible or irreversible. And so examples of this would be a reversible physical change would be like melting ice. This is because you can refreeze the water. So just because you melted the ice cube doesn't mean that you're unable to refreeze it. So it's reversible. What you did can be reversed. And an irreversible physical change good example would be cracking an egg. As you can't put it back together the same way as it was before. So that ends Unit 2.1. And now we'll get into discussion about chemical reactions. So now let's define a chemical property. This is defined as a substance that undergoes specific chemical change. And so, during a chemical change, what do you guys think changes? The what of the matter? Hopefully someone said composition. So, physical change, properties can change, but the composition cannot. And then a chemical change is when the composition of matter changes. So, a chemical reaction is just defined as one or more substances changing into one or more new substances. And so in a chemical reaction, there are two main terms that we have to know: reactant and product. So a reactant is what reacts. So this is defined as present at the start of the reaction. Which leaves us with the product or products. Again, there can be more than one reactant and there could be more than one product. So a product is defined as produced in the reaction. So if we think about the production of water, which we take hydrogen gas and oxygen gas, first thing I'm going to point out is notice these little subscripts with G's and L's. When you're writing chemical equations, those represent what state each of these molecules or compounds or elements are in. In our case, we take hydrogen gas and oxygen gas, and then we're going to turn it into water, which is in a liquid state. So, what are the reactants? Hydrogen and oxygen are our reactants. And then we have water as our product. And all this arrow represents is that there is a change going on. We're going from our reactants changing into our product. Any questions about this? Okay, so there are some clues that could help you determine if a chemical change happened or not. Because like I said, sometimes it's hard to determine if it was just a physical change or if a chemical change actually happened. And so these are some possible clues. The first would be some sort of transfer of energy. So think about the temperature of the reaction. So when you guys did your scientific method lab, if heat was produced or if the baggie got cold, those are signs of a chemical change, as there was a transfer of energy happening. We'll get more into that later on. And then the next possible clue would be a change in color. So think about the first reaction you did for the scientific method lab. You added phenol red, calcium chloride, and sodium bicarbonate. The combination of those three things turned yellow. And then production of gas. And remember that production of gas can mean bubbles or foam, which you should have seen in some of your reactions from that lab as well. And then last but definitely not least is the formation of a precipitate. And so a precipitate is more formally defined as a solid that forms and settles out of a liquid. And so a good example of this would be if you mix two liquids together and something solid ends up forming and sits at the bottom of whatever container you're mixing in, that is a precipitate. But the key thing is we always have to remember the law of conservation, which means mass is not created or destroyed. So, during any chemical reaction, the mass of the products is always equal to the mass of reactants. So that covers units 2.1 and 2.4. Are there any questions?